Hello, we start new chapter, review of vector calculus. This was the first chapter of our subject electromagnetics. The chapter name is vector calculus and these are the subtopic of this chapter. First topic is overview of vector algebra. So in this topic we will study about the what is vector and scalar quantity. What do you mean about 1 dimension, 2 dimension, 3 dimension and 4 dimension quantities? Then we will also discuss about how to add two vectors, what is the vector projection and scalar projection. Then we will study about the next topic is dot product and cross product. Third topic is coordinate system. There are the three coordinate system: Cartesian, cylindrical and spherical coordinate system. Fourth is the conversion of vector from one coordinate to the other coordinate system. Fifth one is del operator, and then after we will discuss about the divergence, gradient and curl operation on vector and scalar quantity. So let us start with first topic, overview of vector algebra. So our topic is electromagnetics. So first, what is the application of this subject, or what is the application of electromagnetics? So actually electromagnetic wave is useful for mobile communication. Okay, there is lots of application. It is also used in medical equipments. Okay, it is used in motor and generator also. Okay, so actually there are lots of applications of electromagnetics. So why this chapter is important, why vector calculus chapter is important? Because whatever the calculation we will do in the next upcoming chapter, okay, we will always consider a vector. Okay, so that is why the vector calculus chapter is important. Okay, and the one more thing is the coordinate system is also important. Okay, and divergence, gradient and curl, these three definitions are very vital. So first topic is overview of vector algebra. Okay, so before start with this subtopic, first of all we will get some simple basic understanding regarding 1 dimension, 2 dimension, 3 dimension and 4 dimension. Okay, so first is, what do you mean by 1D? 1D means 1 dimension. 1 dimension is nothing but is a simple dot. Okay, if I have to do a simple dot, so this dot is indicate is a 1 dimension. Okay, actually it's not a 1 dimension but it's a 0 dimension. Okay, we have to start from the 0 dimension. So dot has no dimension. Okay, second is 1 dimension. 1 dimension means I have to repeat 0 dimension 2 times. Okay, so this dot and second dot. Okay, and if I have to draw a line from one dot to the second dot. Okay, so it's a 1 dimension quantity. Next, number 3 is 2 dimension. 2 dimension means I have to repeat this 1 dimension 2 times. So 1 dimension 2 times. I have to repeat this 1 dimension 2 times. Okay, so the 1 dimension, so it becomes a 2 dimension. I have to just join the corresponding point. Okay, so it's a 2 dimension quantity. Next, 3 dimension. So what I have to do in the 3 dimension? I have to just repeat 2 dimension 2 times. Okay, so first I have to draw a 2 dimension 1 time and 2 dimension second time. Okay, so this one is my 3D picture of view. And now, okay, so this is a 2 dimension 2 times. I have to join the corresponding points. Okay, so it's a 3D, it's a 3 dimension. And what do you mean by 4 dimension? Okay, 4D, 4 dimension. So what I have to do? I have to just draw 3 dimension 2 times. Okay, so what I have to do? I have to just draw a 3 dimension 2 times. Okay, so these are the points of my 3 dimension. Okay, so it's a first 3 dimension. Okay, so it's a first 3 dimension. Okay, now I have to repeat it again. Okay, so if I have to repeat it So we'll repeat here. And then after I have to join the corresponding points. Okay, so this one is my 3-dimension. Now what I have to do, I have to just join the corresponding points. So which are the corresponding point here? So these are the corresponding point. Okay, so I think it should be clear to you how to draw. Okay, so it is known as 4-dimension quantity. Clear? So again, 0-dimension means single point, 1-dimension, 2-dimension, 3-dimension. 3-dimension means, see here, 0. What do you mean by the 0-dimension? 0-dimension means it has a only 2 value. Okay, suppose I will say this value is x value and this value is y value. 1-dimension means only one value, which is x value. 0-dimension means no value. 3-dimension means 3 value, x, y, okay, x, y and z value, x, y and z value. And 4-dimension means 4 value, okay, p, q, r and s, or you can say that x, y, z or any other variable which is t. Okay, so this x, y, z and t. Okay, so these are the dimension. Now we'll study about the what do you mean by the scalar quantity and vector quantity. Okay, so I think we know about it. What do you mean by the scalar and what do you mean by the vector quantity? So this is just a very simple difference between scalar and vector quantity. So first is scalar quantity. So scalar means the quantity which has no any direction. So there is no direction. It has only magnitude. So this is known as a scalar quantity. Okay, so scalar quantity has only and only magnitude or value, but it has a no direction. What is the example of scalar quantity? So example of scalar quantity is pressure. Okay, pressure has a no direction, it is only magnitude. Similarly, temperature. Okay, room temperature is also a scalar quantity, it has a no direction. Okay, it has only magnitude. Okay, suppose my room temperature is, for example, 32 degrees Celsius. So I have to say that everywhere in my room, at every point in my room, the temperature is 32 degrees Celsius. Okay, I cannot say that in one corner the temperature is 30 degree, in the another corner the temperature is 25 degrees Celsius, and the third corner the temperature is some other value. Okay, so we cannot say that in this direction the temperature is different, the other direction the temperature is different. Okay, the temperature is remains same. Okay, actually at the room the temperature is fixed, it's a constant. Okay, it's a 32. Okay, that means the temperature is not vary with the direction. Okay, so that is why the temperature is known as the scalar quantity. Okay, so there are lots of the scalar quantity: pressure, temperature, weight. Okay, clear? So it's just 2 example of the scalar quantity. Second is vector quantity. What do you mean by the vector quantity? So vector quantity has magnitude as well as direction also. Okay, so for example, speed, okay, then velocity, okay, acceleration, all are known as a vector quantity. Okay, force, torque, okay, all are the example of the vector quantity. So vector quantity has a magnitude as well as the direction. Okay, to understand the concept of scalar and vector, I will just give you one small example. Suppose here it is city A and here it is city B. Okay, now one boy driving a car. Okay, so boy driving car from city A to city B. Okay, now what the information is given? The information is given that, okay, now listen carefully, only few informations are given. The information is given that this boy driving a car, okay, boy driving a car with speed, with velocity 60 kilometer per hour. So which information is given? Just magnitude is given, just its value is given. Okay, direction is not specified. Okay, boy driving a car with 60 kilometer per hour. Okay, so in this statement only value is given. But if I have to say boy driving a car with 60 kilometer per hour speed from city A to city B, now in this statement the direction is also given. Okay, so I have to write in this way, V. So here I have to not a vector because here the direction is given. So now velocity is a vector quantity. So boy driving a car from city A to city B with 60 km per hour speed from city A to city B. That means I have to point it in which direction? The boy driving a car in this direction from city A to city B. Okay, so this line is indicate what? The line is indicate the specific direction. Okay, so here I have to mention the direction also. Okay, so for the direction I have to always prefer small a letter from city A to city B. It is known as unit vector. We will discuss about it. What is a unit vector? Okay, so this small a subscript capital A to B means from A city to B city, and this one is known as cap. Okay, so this is a unit vector. Okay, so which information is present here? Okay, so there are the two informations are present here, the first information and second information. Okay, so this first information is nothing but my magnitude. Okay, so this is nothing but my magnitude, and the second information is indicated is a direction. Okay, so a direction. So V is a, so here V is known as vector quantity. Okay, so V is known as the vector quantity. So vector quantity. So here V is velocity and is a vector quantity. So always we have to write vector quantity in this way. So V is equals to 60 km per hour is a magnitude, and in which direction? From city A to city B direction. So what vector is indicate? The vector is indicate magnitude and direction both. Clear? Okay, I will give the example of the scalar quantity also, and it is temperature. Okay, so I can write in this way. For scalar, suppose I have to say temperature is 32 degrees Celsius. Okay, I cannot say that in x direction the temperature is 30 degree, in y direction temperature is 25, in z direction the temperature is 40. Okay, because temperature is a scalar quantity, it has no direction. Okay, so no need to write, okay, or no need to denote here the vector sign because temperature is a scalar quantity. Okay, so this scalar quantity has only and only magnitude, which is 32 degrees Celsius. Okay, so here this 32 degrees Celsius is nothing but it's a magnitude. Okay, so that is why T is a scalar quantity. Clear? So this is a simple difference between vector and scalar quantity. Okay, so what small a subscript AB is indicate is a unit vector. Okay, see here, what is the purpose of the unit vector? The unit vector just give the direction of any vector quantity, nothing else. Okay, a unit vector gives just the direction of any vector quantity. Okay, for example, I have to give one more example. Suppose I would write in this way, force F is equals to 10 Newton. Okay, 10 into N. N is indicate north direction. Okay, or okay, so this NSWE. So force in north direction. Okay, so what this actually indicate? Okay, so here what is tan? Tan is magnitude. What an is indicate? An is indicate is direction of force, and F is nothing but force, and it's a vector quantity. Okay, so F is force and it's a vector quantity. So what is the value of force? The value of force is 10, but in which direction? The direction is an direction. So this unit vector is indicate just direction. Okay, so if you multiply, okay, or if you do any simple product of scalar with vector, with unit vector, so it gives the vector quantity. Okay, so multiplication of scalar quantity. Okay, see here, tan is scalar, but if tan is multiplied with an, so this multiplication becomes the vector quantity. Okay, so tan into an, that means this two quantity are multiplied, so it okay, so it becomes a vector quantity. So what an is indicate? An is indicate unit vector. Okay, so clear? So it's a just simple concept regarding scalar and vector quantity. Okay, so now how can we draw any vector? Okay, so we know that to draw a line we need minimum 2 points. Okay, so suppose the 2 point is given. Okay, so one line is present, so it's a one line. Okay, suppose this is the point is A and B. Okay, so it is known as vector or arrow. Okay, so this vector is pointing from point A to point B. Okay, so you can say this vector has RAB vector. Okay, so what is the name of this vector? Vector is R subscript AB vector, and you can write in this way. So this RAB vector, capital R subscript AB. So this RAB vector means from point A to point B. So it's a vector quantity. Okay, so I will just give simple introduction about how to draw a vector and how to calculate its magnitude and its unit vector. Okay, so I will take the example of one coordinate which is known as the XYZ coordinate, Cartesian coordinate system. So you will get the easy understanding about how to draw any vector quantity. Okay, let us draw Cartesian coordinate system. So these are the three axes. Okay, I have to consider is x, y and z axis. All the three axes are perpendicular to each other, that means it makes 90-degree angle. Okay, now I want to locate some point. Okay, so this point is known as my origin. What is the coordinate of the origin? The coordinate of origin is 0, 0, 0 is the coordinate of the origin. Okay, now for example I want to locate one point, point P. I want to locate some point P, and the value of point P is 2, 3, 4. Okay, value of point P is 2, 3, 4. What it indicates? It indicates that in x direction it covers distance 2, in y direction it covers distance 3, in z direction it can cover the distance 4. Okay, now I want to look at this point on the XYZ coordinate system. So how can you look at this point? So first I am standing here. Okay, the person is standing at the origin. Now person cover 2 step in x direction, so person cover 2 step in x direction, person cover 3 step in y direction. Okay, and person cover 4 step in z direction. Clear? So here I have not mentioned the negative x, y and z axis. So these are the positive x axis, positive y axis and positive z axis. Where is negative x axis? Okay, so this axis is negative x axis. Which one is the negative y axis? This axis is my negative y axis, and this one is my negative z axis. Okay, now I want to locate this point 2, 3 and 4. Okay, so how can you locate it? So first the person cover, okay, initially the person is standing at the origin. Now the person cover 2 point, okay, in the x direction. So now this one is the position of the person. Now this person cover 3 point, okay, or 3 step in the y direction. So 1, 2 and 3 step in the y direction. Now this one is the position of the person. Okay, and last the person cover 4 step in the z direction. Okay, so 1, 2, 3 and 4 step. 4 step in the z direction. So now this one is the final position of that person. Okay, so I will just draw this. So this point is nothing but my which point? Point P. Okay, so this one is point P, which is a coordinate 2, 3 and 4. Clear? So what I have to do here, the person cover how much distance in the x direction? The person cover 2 distance in the x direction. Okay, so this one is 2, and the person cover how much distance in the y direction? Person cover the 3 step in the y direction and 4 step in the z direction. 4 step in z direction. Clear? Okay, so this one is the final position of point P. Okay, so now I have 2 points. First is origin point. Okay, and what is the value of origin? The coordinate of the origin is 0, 0, 0, and the second point is point P, which is the origin 2, 3 and 4. Okay, so this one is the z. Clear? So now you can easily observe in a 3D plane. Okay, now it's a completely clear picture. Okay, so now I will draw a vector. Okay, so to draw a vector we need at least 2 points. Here I have to point at point A and point B, but here the point P is given. Now I want to draw a vector, but here only 1 point is present, but I have a reference point which is origin. So now 2 points are present. Which are the 2 points? O point, origin point and P point. Okay, so now I have to draw a vector from origin to point P. Okay, so this one is the vector from origin to point P. Okay, so this vector, this particular vector is known as ROP vector. Okay, this vector is known as ROP vector. ROP vector means from O to P vector. Okay, from origin O to P vector, so it is known as ROP vector. So what is the value of ROP vector? How can you calculate ROP vector? Okay, so actually where is the head? Here is the head. At the point P it is head, and at the point O is a tail. Okay, so ROP vector means point P minus point O. Okay, means head minus tail. Okay, so the head coordinate is 2, 3, 4, tail coordinate 0, 0, 0. Do the simple subtraction. So if you do the simple subtraction, 2 minus 0, 3 minus 0, 4 minus 0, so answer is 2, 3, 4. But actually it's not a vector, it indicates just a simple point. So to draw in terms of vector, I would write 2. Okay, so actually 2 in which direction? 2 in x direction, so I would write 2ax plus 3 in which direction? 3 in the y direction, 3ay plus 4 in which direction? 4 in the z direction, so it is 4az. Okay, so here it is a ROP vector P minus O, and this one is the value of ROP vector. Okay, so as we know that vector has a 2 things. Okay, any vector quantity has a magnitude as well as direction. So here I have to write R subscript OP is a one type of vector quantity, and this one is the value of this vector. Okay, now how to find out the magnitude of this vector? Okay, so to find out the magnitude ROP vector, you can write in this way, or you can write simple ROP. It also indicates the magnitude of this vector quantity. It is nothing but under root of 2 square plus 3 square plus 4 square. Okay, so it is under root of 4 plus 9 plus 16, so it is 29. Okay, so it is a magnitude of this vector. Okay, and what the magnitude is indicate? The magnitude is indicate is nothing but the length of vector. Okay, the magnitude is indicate length of vector. indicate the length of vector. Okay, so it is the just magnitude of the vector. Next, how can you calculate the unit vector, or how can you calculate the direction of vector? Okay, so what is the definition of unit vector? Okay, vector divided by its magnitude, so it is known as unit vector. Okay, see here v is a vector, this one is magnitude, and this one is its direction or unit vector. So how can you find out the unit vector? Vector divided by its magnitude, so you can easily find out the unit vector. Okay, so here the vector is which one? ROP vector. So how can you find out the unit vector of ROP? Vector divided by its magnitude. Okay, so unit vector of ROP, unit vector of ROP is equals to ROP vector divided by its magnitude. Okay, so what is ROP vector? ROP vector is 2ax plus 3ay plus 4az divided by under root of 29. So this one is a unit vector. And what unit vector is indicate? Unit vector is indicate just direction of that vector quantity. Okay, so this one is just example of how to find out the magnitude and unit vector of any vector quantity. Okay, I will give you one more example so you will get the clear understanding about how to find out the magnitude and unit vector of any vector quantity. Okay, just take one more example, then we will proceed to the next topic. Suppose vector is given. Okay, vector A is given. Okay, so vector A is ax minus 3ay plus 2az. Okay, now the question is, what do you mean by ax, what do you mean by ay minus 3y, and what do you mean by plus 2az? Actually it indicates the weightage of this vector. The weightage of vector A in x direction is 1, the weightage of this vector in the y direction is minus 3, and the weightage or the value of this vector in the z direction is 2. That means this vector is present in all the three axes, in x, y and z axis. The vector is present in all the 3 x, y and z axis. Okay, now as per the definition, vector A is equals to magnitude of vector A into its unit vector. Okay, and how can you write the unit vector? We have to just write, see here, how can you write unit vector of any vector? I have to just write small a and then subscript of that vector and then cap. Okay, so what it indicate? It indicate unit vector. Okay, so this one is magnitude of the vector. What it indicate? It indicate direction, or you can say unit vector. And if you multiply magnitude and unit vector, so we will get our vector quantity back. Okay, so what we have to do? We have to, first of all, we have to find out magnitude of vector. So how can you find out the magnitude of the vector? So first, magnitude of vector A, or you can write just A. Okay, it is nothing but under root of 1 square plus minus 3 square plus 2 square. Okay, so it is 1 plus 9 plus 4. So answer is under root of 14. Okay, so this one is the magnitude of the vector. Now how can you find out the unit vector? So unit vector of vector A is equals to the given vector divided by its magnitude, or you may write in this way also, vector A divided by A. Vector A is ax minus 3ay plus 2az divided by its magnitude under root of 14. Okay, now the question is, why it is known as unit vector? because if you find out the magnitude of unit vector, so it is always 1. Okay, see here, I will just do this. Find out the magnitude of this unit vector. Okay, so magnitude of unit vector, that means magnitude of this quantity. Okay, so 1 upon under root of 14 is a common here, 1 square plus minus 3 square plus 2 square. So it's under root 14 divided by under root 14, so this is 1. Okay, so 1 is unity. Okay, so that is why it is known as unit vector. So actually, what is the okay, so it's a short question. What is the magnitude of unit vector? Magnitude of unit vector is always 1. Okay, so that is why if you multiply unit vector with any magnitude, the magnitude is unchanged. The magnitude remains unchanged. Okay, it never alter the magnitude, it only give the direction of this vector quantity. Okay, so if you multiply any scalar quantity with unit vector, so it will give your vector quantity. So what is the purpose of unit vector? Unit vector just give the direction of any vector quantity. Okay, so it is the purpose of any unit vector. Okay, now we discuss about addition of two vector. Okay, it's very easy how to add two vector, how to subtract two vector. Okay, so no need to discuss about it. But as we know that any vector quantity has a two part. One is perpendicular, okay, or normal part, and second is a tangential part. Okay, for example, suppose I have one vector. Okay, I have to draw one vector. So this one is my vector A. Okay, now this vector A has a two part. Okay, so this vector A has a two part, first part and second part. Okay, so suppose I have to say that this vector makes some angle, okay, with respect to this line, and this angle is nothing but theta angle. Okay, so this vector has a total two part. First is normal part, which is perpendicular, and second is a tangential part. Okay, or you can say that vertical part and horizontal part. Okay, so what is the magnitude of this horizontal vector? Okay, it's very easy. The magnitude is horizontal vector is A cos theta. Okay, this one is A cos theta, and this one is A sin theta. I will just apply the trigonometric concept. And what is A? A is the magnitude of this vector. Okay, now see here, for example, to draw, okay, as we know that to draw a vector we need at least 2 points. Okay, so here there are the 2 points. Suppose this point is point O and this point is point P. So you can write a vector in this way also, vector A, or you can write ROP. Okay, you can write a vector as a ROP vector also, because what do you mean by ROP? ROP, it indicates is a vector which is pointing from O to P, and we always prefer R, okay, for the vector. So this R subscript OP. Okay, or you may give any name, X, Y, Z, you may give any name. Okay, it's not compulsory to give capital A, capital B, you can give any name. Okay, so generalized name is ROP vector. Okay, so here if vector makes any angle with respect to any surface or any plane, so you can split this vector into the two part. First is vertical part and second is a horizontal part. Okay, so this one is just a simple concept. Okay, so this topic is related to the overview of vector algebra. There are so many topics are present, okay, but no need to discuss about it because all of you know about it. Okay, how to find out the addition, subtraction of any vector quantity. Okay, now we have directly jump to the next topic, which is dot product and cross product of any vector. Okay, so as you know that what do you mean by AX, AY and AZ? Okay, so again how to draw 3 axes, X, Y and Z. It is Cartesian coordinate system. Okay, and suppose I have to write one vector. Okay, so vector A is equals to 2ax plus 4ay plus 3az. So what it indicates, what these values indicate, it indicates that the weightage of vector A in x direction is 2. So in x direction the weightage of vector is 2, in y direction the weightage of vector is 4, and in z direction the weightage of vector is 3. Okay, so you may write in this way also, vector A is equals to capital ax plus small ay plus az and az. You may write in this way, okay, where what is ax? Ax is 2, ay is 4 and az is 3. So these are the weightage, or these are the value of this vector in x, y and z direction. Okay, so mostly the most of part of the vector in which the maximum part of the vector in y direction and the minimum part of the vector in the x direction, you can say in this way. Okay, see, I will give you one example so we will get the idea of this. Okay, it's a good example. Suppose force F is equals to ax plus 2ay plus 100 az. Okay, this one is a good example. So force F is equals to ax plus 2ay plus 100 az. So what it indicates, how to apply a force on some object in x direction, in y direction and in z direction also. Okay, so how to apply a force on some object in x direction. So what is the value of x direction? Okay, what is the value of force in x direction? So force in x direction is very low, which is 1. What is the value of force in y direction? It is 2. And what is the value of force in the z direction? It is very high, and it is 100. So obviously the object move in which direction? The object move in z direction, because I have to apply a maximum force in the z direction. Okay, so the object move in the z. Okay, yes, the object slightly move in x and y direction also, but the value of force in the z direction is very high compared to x and y direction. Okay, so ideally we can speak in this way, the object is move in z direction. Okay, because we have to apply the more force in the z direction. Okay, so this one is the meaning of ax, ay and az. So actually ax, ay and az is a weightage of vector in x direction, in y direction, in z direction. So what is the meaning of ax, ay and az? So ax is indicate the unit vector in x direction, ay is indicate unit vector in y direction, and az is indicate unit vector in z direction. Okay, so now next topic is product of vector. Okay, so there are the two types of product, dot product and cross product. Okay, so next topic, product. No need to discuss about addition of two vector and subtraction of two vector, because it's very easy. We have to just do the addition as a simple addition. Okay, so there are the two types of the product. First is dot product and second is cross product between two vector. So here I have to take vector A and vector B. Okay, so dot product means I have to just put a dot between vector A and vector B, so this is known as dot product. And what do you mean by the cross product? I have to put a cross A vector cross B vector, so this is a cross product. Okay, there are the major difference between this dot and this cross. Okay, so we'll discuss about it, what is the meaning of this dot and this cross. Okay, so here I have to just first we have discussed about the dot product. Okay, so I have to just take the example of one vector A. Okay, so here A dot B. Okay, so what is the equation of dot product? A vector dot B vector is equals to magnitude of A vector magnitude of B vector into cos theta. What is theta? Theta is angle between two vector. Okay, see here, suppose I have a vector A, this one is my vector A, and the second is my vector B. Okay, so the main thing is tail. Okay, the tail of these two vector is common. Okay, the tail of the two vector are common, and this one is the angle theta. Okay, so angle theta is nothing but it's a angle between two vector, vector A and vector B. So what is the dot product between two vector? Mode of A, mode of B into cos theta. Okay, so you may write in this way also, A B cos theta. Okay, it's not a in our syllabus how this equation comes. Okay, but we are direct. Okay, you can directly write this equation this way: A vector dot B vector is equals to AB cos theta. Okay, so if two vectors are given, so you can find out the angle between two vector. How can you find out the angle between two vector? Just we have to do the dot product between two vector, and then we have to divide this dot product with the magnitude of these two vector and find out the cos inverse. So you can easily find out the angle between vector A and vector B. Okay, so it is just a dot product between vector. Okay, so dot product between two vector is AB cos theta. Okay, so now I'll just pick up some small example. Okay, so I'll again write dot product between two vector, vector A dot vector B is equals to magnitude of A, magnitude of B into cos theta. What is theta? Theta is nothing but the angle between two vector. Okay, now to just take the first example, suppose vector A is equals to AX and vector B is also AX. Okay, so what is the dot product between these two vector? So vector A dot vector B is equals to A. A is the magnitude of A vector, is AX, so its magnitude is 1 dot. B is AX, so magnitude is 1. And what is the angle between A and B? So if you notice, A is in which direction? X direction. B is only X direction. So both the vector are present in X direction. That means both the vector are parallel to each other. Okay, so if two vector are parallel, so what is the angle between two vector? It is 0. So it is cos 0. So cos 0 is 1. So answer is 1. Clear? Similarly, if vector A AX, vector B is AY, then do the dot product between two vector, A vector dot B vector. Magnitude of A 1, magnitude of B 1, and what is the angle between X and Y, AX and AY? It is 90 degree. So cos 90 and cos 90 is 0. So it's 0. Okay, so the final conclusion is that we have derived here AX dot AX. Okay, see here, A vector dot B, value of A is AX, value of B is AX. So AX dot AX. Okay, so I can write in this way, AX dot AX, answer is 1. Okay, similarly AY dot AY, answer is 1. Okay, AZ dot AZ, answer is 1. But AX with different unit vector AY, these two are perpendicular, so answer is 0. AX with AZ, answer is 0. AY with AZ, so answer is 0. Okay, because Y and Z, X and Z, X and Y are perpendicular to each other, it makes 90 degree angle, so answer is 0. Okay, so this one is nothing but the dot product between two unit vector. Okay, so finally we can conclude that dot product between two same unit vector, answer is 1, but dot product between two different unit vector, answer is 0. Okay, so this is the meaning of dot product. Okay, now I will give one assignment. Okay, so or one example is vector A is given, vector A is equals to AX plus 2ay, vector b is equals to 2x minus 3ay plus az. Find angle between two vector. Find out angle between vector A and vector B. Okay, so is one small questions for assignment. The vector A and vector B is given. Find out the angle between two vector. We will discuss this example, okay, in our next video lecture class. Okay, so it's just a dot product between two vector quantities. Okay, next is a cross product between two vector quantities. Okay, so what is our conclusion of if we do the dot product between two vector quantities? Okay, so say if we do the dot product between two vector quantities, so answer must be a scalar. Okay, see here I have a small sum part of this example. Okay, so just do the dot product between A and B, A dot B. How can you do the dot product between these two vector? So I have to apply the direct method. See here, it is ax plus 2ay dot with 2ax minus 3ay plus a. Now to do the dot product between these two vector quantity. Okay, so first I have to pick up this ax dot with 2x, then ax dot with minus 3ay, ax dot with az, then next 2ay dot with 2x, 2ay dot with minus 3ay, 2ay dot with az. Okay, so if you do the dot product between ax and ax, answer is 1. If you do the dot product between ax and ay, answer is 0. So no need to do the dot product between ax and ay. Similarly, no need to do the dot product between ax and az because answer is 0. So whenever we have to do the dot product between two vector quantity, we always prefer the dot product between two similar unit vector. So ax dot 2ax, answer is 2. Okay, because here it is 2, ax dot ax is 1, so 2 into 1, 1. Okay, similarly for y, 2ay into 3ay, so 2 into minus 3 minus 6, ay dot ay 1, and here no z term is present. Okay, that means 0 az with 1 az, so answer is 0. Okay, so here 2 minus 6, answer is minus 4. Okay, so if you do the dot product between two vector quantity, answer must be a scalar quantity. Okay, so see here the 4 minus, our answer is minus 4. Whatever the answer you get is always a scalar. So if you do the dot product between two vector quantity, answer is always and always scalar quantity. Okay, so keep it in mind. Next, we discuss about the cross product between two vector quantity. Okay, so how can you find out the cross product between two vector quantity? So first of all, keep in mind, if you do the dot product between two vector quantity, okay, if you do the dot product between two vector quantity, answer is scalar quantity. In a reverse way, if you do the cross product between two vector quantity, answer must be a vector quantity. Okay, so the new vector is generated. If you do the cross product between two vector, the new vector is generated. Okay, so next topic is cross product between two vector. Okay, and this one is important. Okay, so next is cross product between two vector. Okay, so first of all I will write the equation. Suppose vector A is given and vector B is given, so vector A cross vector B, so answer is mod of vector A mod of vector B, or you may just write A into B sin theta. Okay, or you may just write AB sin theta, and here it is AN. Here also AN. We'll discuss what is AN. Okay, so here two vectors are given. Vector A is given and vector b is given. Okay, and theta is nothing but angle between vector a and vector b, which is theta. Okay, now see how to do the cross product between two vector. So the new vector is generated in which direction? Okay, so here this one is the direction of vector a, this one is the direction of vector b. So if you do the cross product between two vector quantity, the new vector is generated in which direction? So new vector is generated which is perpendicular to the plane of vector a and vector b. Okay, so this new vector is generated, and this new vector is always perpendicular to this vector a, and this new vector is also a perpendicular to vector b. Okay, so the new vector is generated, and this new vector is always perpendicular to the plane of vector a and vector b. Plane of vector a and vector b means this white page is known as plane of vector a and vector b, because vector a and vector b exist in this plane. Okay, so whatever the new vector is generated, it is always perpendicular to the plane of vector a and vector b, or you can say that the new vector is perpendicular to vector a and this new vector is perpendicular to vector b also. Okay, so which rules we have to use? Actually we have to apply a screw rule. Okay, we have to always prefer a screw rule. Okay, so if suppose I have one screw, simple screw, okay, and I have to rotate the screw in clockwise direction. Okay, so screw goes inside in the page. If I have to rotate in the clockwise direction, so screw goes inside the page. But if I have to rotate the screw in anti-clockwise direction, so it is outside of the page. Clear? So here I have to do the cross product between a and b. That means first I have to pick up which vector? Vector a, and then I have to go to vector b. That means I have to go from a to b. See, I have to go from a to b. Okay, that means in which direction? I have to prefer a clockwise direction. Okay, I have to prefer here a to b, a cross b. That means I have to prefer a clockwise direction. Clockwise direction means the resultant vector is inside the page. In a reverse way, if I have to do b cross a, okay, b cross a means in anti-clockwise direction, so resultant vector is outside of the page. Okay, so what is the magnitude or what is the value of this a cross b vector? Okay, so whatever the new vector is generated, so this one is my new vector and it is inside the page. Okay, because there is a cross b, so the new vector is inside the page. Okay, so what is the magnitude of this new vector? The magnitude of this new vector is a into b sin theta. And what an is indicate? This an is indicate the direction of this new vector. And why I have to prefer an? N is indicate normal. Normal means perpendicular. So whatever the new vector is generated is always perpendicular to this plane. Okay, so that is why I have to prefer n. N means normal, means it is perpendicular. Okay, so this one is the magnitude of the new vector which is generated and an is direction or unity vector. Okay, so this one is a cross product between two vector quantity. Okay, so you can, okay, so we can say that here if you do a cross b is not equal to b cross a, huh? Because just the direction is different. If you do the a cross b, the resultant vector is inside the page, and if you do the b cross a, the resultant vector is outside of the page. The magnitude remains same, but just the direction is different. So you can write a cross b is equals to minus b cross a. But what about the dot product? A vector dot b is equals to b vector dot a. Okay, so for the dot product, it doesn't matter whether it is a dot b or b dot a, but for the cross product, it is matter. Either it is a cross b or it is b cross a. Just the direction is changed, the magnitude remains same. Okay, so it is a cross product between two vector quantities. Okay, so I have to just take one example and then we have to finish this topic, dot product and cross product. Okay, so take one example. I have to consider that A is equals to AX, B is equals to AX. Okay, so what is A vector cross B vector? A vector cross B vector is equals to AB sin theta. A is magnitude, B is magnitude. So what is the magnitude of A? 1. What is the magnitude of B? It is 1. Sin theta. Sin theta. Theta means the angle between A and B. Okay, A in the x direction, B is also in the x direction. Both are parallel, so angle is 0. So this sin 0, sin 0 is 0. So answer is 0. Okay, next example. A is equals to AX and B is equals to AY. Okay, now find out A cross B. Okay, so magnitude of AX is 1, magnitude of AY is 1, angle between X and Y is 90 degree, so this sin 90 degree. Sin 90 degree means 1, but here AN terms means the term which is perpendicular to the plane of AB. So which vector is perpendicular to AB? So see here, A in the x direction, B in the y direction. So which vector which is perpendicular to A and B? Always z direction. So here I have to write AZ. So 1 into AZ. So answer is AZ. Okay, so AX cross AY, answer is AZ. Okay, so we can conclude that for the cross product AX cross AX, answer is 0. Similarly, AY cross AY, answer is 0. AZ cross AZ, answer is 0. But AX cross AY, answer is AZ. Similarly, AY cross AZ, answer is AX. Okay, AZ cross AX, answer is AY. See here, the pattern must be remains fixed here, X after Y and then Z, and again it is repeated. Okay, so X after it is Y, after it is Z, and again it is X, Y, Z. This pattern must be followed. Okay, see here, here it is X, after X it is Y, so after Y it is Z, again Y, after Y it is Z, and after Z it is X. Okay, so pattern must be followed. In this case, first is Z, after Z it must be X, yes, so it is correct, and after X it is Y, and after Y again it is Z. Okay, for example, suppose it is AZ cross AY. So what should be the answer? So see here, first it is AZ. Okay, after Z it should be X, but here it is Y. Okay, after Z it should be X, but in our question after Z it is Y. Okay, so actually here Z and Y, so answer is X, but it is not positive X, it is negative Y. Why it is negative Y? Because it is Z, after Z it should be X. Okay, so actually it's a reverse way. Actually it's a reverse. Okay, or you can write in this way also. Okay, you can write in this also, minus AY cross AZ is equals to AX. Now it is correct. See here, Y, Z, and then X. So I have to just write here negative sign. I have to follow these rules. A cross B is equals to minus B cross A. Okay, so it's just a simple dot product and cross product between two vector quantities. Okay, so you can solve so many numericals based on cross product and cross product, how to find out unit vector, how to find out the magnitude of any vector quantity, how to find out the angle between two vectors. Okay, so in next lecture we will discuss about the next topic, which is coordinate system, and then how to convert a point and how to convert a vector from one coordinate system to the another coordinate system. Thank you.